Hello students, in the next 10 to 15 minutes I will be discussing about tensor analysis. Students normally find difficult this topic, tensor analysis. So I will touch some basic points of tensor within very short time. So let us start. We know scalars. What are the scalars? Scalars generally have magnitude and unit, and scalars are included as zero-rank tensors, right? And next, vectors. Vectors are specified by magnitude and directions. So vectors are called rank 1 tensor. On the other hand, tensors are associated with 2 or more directions. Okay, so rank 2, rank 3, rank 4 tensors, etc. Right? One of the example of tensor is stress tensor. If we consider an elastic solid and stress applied on a particular point, then it will have two directions. Number one, along the normal to the area of the cross section. Number two, along the force on it. Okay. The important point is that tensor can be specified only by its components, which depends upon the system of reference. The components of the same tensor will be different for different sets of axes with different orientations. If the axis orientation is different, then the components of the same tensor will be different. This is an important point. So let us see what are the advantages of tensors. I'm giving two important advantages. Number one, natural laws are invariant with respect to different frame of reference. This is very important. The another advantage is that transformation equations from one coordinate system to another coordinate system can be written in more compact form by using tensors, right? Due to these reasons, Einstein used tensors for formulation of special theory of relativity. Okay. Let us see how coordinate system transformation is obtained. So we have here two rectangular coordinate systems, S and S dash, right? And a particular point P has coordinates x, y, z with reference to the first coordinate system S, and x dash, y dash, z dash to the second coordinate system S dash. Okay, so full line gives the first coordinate system x, y, and z, and the dotted line gives the second coordinate system x dash, y dash, z dash. So another important point is that here the direction cosines of axes ox dash, oy dash, oz dash relative to the system ox, oy, oz are L1, M1, N1, L2, M2, N2, and L3, M3, N3. These are the L1, L2, L3, M1, M2, M3, N1, M2, N3. Okay. And then we have x dash, y dash, z dash like as given by this equation, L1x plus M1y plus N1z. Similarly, y dash and z dash can be obtained like this. So as you know, direction cosine. What is direction cosine? So let me give you a simple idea about direction cosine. Suppose this is a vector. Okay, if this origin is O, OP is a vector. Okay, this vector makes different angles with different coordinate axes. Suppose if it makes an angle alpha with the x-axis, okay, then cos alpha is the direction cosine, that is represented as L1. Okay. Similarly, if it makes an angle beta with the y-axis, okay, then cos beta will be the direction cosine, which is represented as M. Okay. Similarly, if it makes an angle gamma with the z-axis, then cos gamma is the direction cosine. Similarly, these direction cosines are assigned for all six coordinate axes, right? Now, how we can formulate all these equations with a table? In this table, x, y, z, x, y, z, if you write like this, and the direction cosine of x, here you see L1, L2, L3, L1, L2, L3, and for y, M1, M2, M3, for z, N1, N2, N3. Then you can easily get this equation, first equation. Suppose x, you want to find out x, then x is equal x L1 plus y M1 plus z N1, okay, z N1. Similarly, you'll find another equation for y and z also. And the second sets of equations, suppose you want to find out x. If you want to find out x is equal L1 xs plus L2 y plus L3 z. Okay. So if you write this table, then you can easily find out these 6 equations. Xs in terms of x in terms of xs. Okay. So next, let us see some basics rules of tensors. For example, this is one of the series a1x1 plus a2x2 plus a3x3 plus a4x4 like this up to n, suppose. This is in brief, we write like this: summation sign I is equal to 1 to n aixi. Okay, so I stands for 1 to n. Okay, but Einstein used more compact notation as a ixi. Okay, like this you see a1x1. Okay, this x1 is not power. The x1, x2, x3, 1 is not power. 1, 2, 3, etc. upon x do not represent the power. It is just a notation. Just like this. Here we write a suffix, subscript 1, 2, 3, but here in the form of power, but it do not mean power. Okay. Here summation symbol is not written. Summation is not written here. If somebody want to write the power of this, then it is written like this, within bracket xi to the power 2. Okay. So powers is written like this. Next, another example of expanding a tensor. Suppose this is a notation rs, okay, br. Okay, so we have 3 components, notations rs, 1, 2, 3, 4 up to n. Okay, r and s has values, changes values from 1 to n. Okay, according to this example, we are to expand this notation. Suppose how it is expanded. So first of all, in place of our r, we write 1. Okay, r is equal to 1, 2, ... n. Okay, so s is not expanded in the first case. Okay, in the right hand side, it is r, br. In place of r, you can write 1, 2, 3, etc. up to n. Okay. Secondly, only this term is only this term is expanded as now. In place of s, suppose you see here s. In place of s, you are writing 1. Okay, 2, 3 up to n. So 1 is okay. You are not changing 1. Only this term is within bracket expanded. Now come to the second point. 2 will be everywhere. Okay, a2 will be everywhere, but you just have to change the value of s. Okay, 2, 1, 2, 2, 2, 3, etc. So the s will change. There are 2 s's. One s is here, one s is here. Okay, so you have to change the value of s from 1 to n, but 2 will remain same. In this way, you have to expand each and every point in the left hand side. Right hand side will be same. This is the way of expansion. Okay. Next, this is another system Here summation of coordinates. Let us represent x1, x2, x3 and x1 bar, x2 bar, x3 bar instead of x, y, z and x dash, y dash, z dash. And also represent the coordinate axis as ox1, ox2, ox3 and ox1 bar, ox2 bar, ox3 bar. And also xi and xj bar represent the coordinate of a point P where I, j represent 1, 2 and 3. Okay. And Lij denote the cosines of the angle OXI and OXJ bar. So we have two coordinate system, S and SJ again, but in this case, instead of writing XYZ, we are writing just X1, X2 and X3. That is simply you can consider that 1, 2 and 3 represent X, Y and Z, right? And also for another coordinate system, we are giving just bar, X1 bar, X2 bar and X3 bar, okay? X3 bar represents Z dash axis. Earlier we have taken. Now here also direction cosines, nature of direction cosines also changes. We are using notations here. For example, L11, L12, L13, right? 1, 1, 1, the first suffix, it represents I. And second suffix, 1, 2, 3, it represents for Z. Okay. So for x1, that is x-axis, this is x-axis, we are representing here x1. We are writing L11, L12, L13. And for the second axis, that is y-axis, we are writing here x2. Here the cosines, direction cosines are written as L21, L22, L23. Okay, 2, 2, 2. That is 2, 2, 2 represent for y-axis. Similarly, for z-axis, we represent 3, 3, 3. Okay. And here we are not writing LMN. We are just giving the notations. Okay. And second coordinate system, x1 bar, we are writing L11, L21, and L31. Just see the notations 1, 1, 2, 1, 3, 1. Okay. In this case, the z value is 1. For x1 bar, the z value is 1, 1, 1. Okay. Similarly, for y dash bar, this is y dash, the z value will be 2, 2, 2. For z dash axis, the z value will be 3, 3, 3. Okay. This is simple. And for next C, from this we can have a tabular form as x1, x2, x3. Similarly, x, y, z. And x dash, y dash, z dash, we are writing here x1 bar, x2 bar, x3 bar. So in this case, we are writing L11, L12, L13. Okay. So to find the equations for transformation equations for x1 bar with respect to x1, x2 and x3, we will get this row. This row will give the first equation as this x1 bar L11 into x1. This is plus L21 into x2, x2c plus L31 into x3. Okay, this is first equation. For the second equation, L2 bar, x2 bar, you'll get similarly, you'll get L12 into x1. This is L22, x2, L32, x3, like this. Similarly, we'll get the third equation also. For x1, x2, x3, for second set of equation, we'll get same way. For x1, suppose you're multiplying x1 bar by L11, L11 x1 bar, L12 x2 bar, L12 x2 bar, L13 x3 bar, you see. Similarly, for x2, you will get this equation, x. For x3, that is z, you'll get this equation. If we adopt summation convention rule for aij, suppose a11 plus a22 plus a33, or this is aipbiq is equal, if you expand this, in place of I, you can write 1, 1 and 2, 2 and 3, 3. You can expand it. We can rewrite the above equations. We can rewrite this equation as, you see, for first equation, this x1, x1 L11 x1, okay, x1 L21 x2 plus L31 x3, okay. See, yet x1 x2 x3, instead of writing 1 2 3, we're writing just xi, so that we can put the value of I as 1 2 and 3, right? For second set also we'll get the same short compact notation. For this x2 bar, for the second equation x2 bar, okay, so x1 2 3, instead of writing 1 2 3, this is summation, so we are writing just I, so that we can put the value of I as 1 2 3. This is L1 L2 L3, okay. This is I 1 2 3, so I 2 2 2 same, so 2 is written here, okay. For the third equation 3 3 3 same, but 1 2 3, 1 2 3, for 1 2 3 we are writing I, so 1 2 3, for x we can writing I, okay, x3. Similarly, for another 3 equations, we'll get these compact equations, so that we can put the value of I and j only, okay. But in this case, when x bar, you will get x bar 1, x1 bar, x2 bar, x3 bar. Instead of writing I, you will have to write j here, okay, j. In this case, you will write to z. Suppose x2 equals this equation, x1 bar, x2 bar, x3 bar. So you are writing xi bar, xj bar, not I, xj. For this, you have to write j, okay. Similarly, this notation, suppose 2 1, 2 2, 2 3, 2 2 2, the value of I is remains same, but 1 2 3, the second suffix which represents j, it is, instead of writing 1 2 3, you are writing only j, okay, j, okay. 2 is repeating here, 3 is repeating, so 3j x bar j, okay. In this way, single out of these 3 equations, you can have another single equation. How? You see, this equation xj xi, lij xi, instead of 1 2 3, you are writing I, okay, xij, so I repeating, so xi is j is second suffix 1 2 3, j xi. Out of these 3 equations, no need to write 3 equations, you are writing on a single equation, okay. Similarly, out of these 3 equations, you can have a single equation. How? You see, x1 2 3, 1, instead of 1 2 3 writing, you are just writing I, so that you can put I in place of I 1 2 3, okay. Out of this equation, you will get 3 another equations. Similarly, L1j, that is 1j, that is xj bar, okay. J is simple, okay. So it should be not I, it's wrongly written, it should be I, okay. 1 2 3, it should be 1, Lij, it is by mistake it is written as 1. It is should be I. Okay, Lij, it should be Ij, so that 1 2 3 can be written as I. Okay, similarly it is xj bar xj bar. Okay, thank you. Okay.